Hi folks, today's little assignment is all about something called resistance. We've already learned about potential difference or voltage. Resistance is another number associated with circuits which we need to understand. Resistance is a word that you've seen before, and your understanding of what it means to resist something can help you here. If you look at this corridor, think about how easy it would be to walk from one end of the corridor right to the other. There's no one there, it's a nice wide corridor. It's going to be pretty easy to walk from one end of this corridor to the other. This, if we were using this as an analogy to think about a component in a circuit, we would say that this had a low resistance, because it's easy to get from one end to the other. Now, that doesn't mean that if you put a low resistance component in a circuit, it's empty of stuff. We'll come on to why things are good resistors or bad resistors, or good at letting things move through them in a circuit, or bad at letting things move through them in a circuit another time. But for the time being, if something's got a low resistance, it lets the charges in the circuit flow through it really easily, as opposed to, say, this corridor where there is a lot of resistance. If you imagine trying to start, say, at this end here and walk all the way to the other end of the corridor, it's going to be really difficult for you. You're probably even going to have to push a little bit harder, and it will take you a long time. So if we were thinking of this as a circuit component, we would say that this had a high resistance, because it's really difficult to get from one end to the other. Now, what I want you to do is come back to this circuit simulator, this circuit construction kit, and you can build a really simple circuit this time, just like this here. I've added an extra thing to this circuit this time, which we didn't look at last time, which is this thing here. That lives there, and you can just click it and drag it and place it down. When you click it again, just click on this little crosshair here and place it over one of the wires, and you should get a number show up. The way that I've set this circuit up, this battery here, this cell, has got a voltage, a potential difference of 25 volts. You can change that if you build your circuit, click on the component. You can then just click these around like that, or you can drag the slider, but it's quite difficult to get it exactly where you want it to be, so you might need to drag it and then just do a couple of clicks like that. You can do the same with the bulb. The way I've set mine up is to have a resistance of 5, and the units for resistance are ohms. So when I've got a resistance of this bulb of 5 ohms, I get a current of 5 as well. The units of current are something called amps. We're going to do a whole proper lesson on current another time, so you just need to know that it's 5 for the time being. Now, you might notice that if I've got a resistance of 5 and a current of 5, my voltage is 25, those three numbers are linked. If I do 5 times 5, so 5 ohms times 5 amps, I get 25. That might just be a coincidence, but let's change our resistance a little bit and see if we can get something else to happen. And you might see, as soon as I started moving this slider, the current is changing over here. As I make the resistance higher, the current decreases. And you can think of that a bit like the corridors. So this has got a low resistance, so you'd have a really high current. It's really easy to walk straight through. That's kind of what current is. It's how easy is it to walk through. As I increase the resistance, so maybe I put in a few obstacles, maybe I put in a few more people, it gets harder to walk through, so the current is lower. And then when I put the resistance very high, the current becomes very low, because it's really difficult to walk through. And that's just what's happening here. As I increase this resistance, this current gets smaller. But you notice I've got 10 ohms here and 2.5 as my current. Well, 10 times 2.5 is still 25. If I increase this again to 12.5, 12.5, my current has decreased, now 2. 12.5 times 2, still 25. If I increase this again, let's go for 25. 25, my current is now 1. 25 times 1, 25. If I keep going, this number here is going to become less than 1. And you should have seen in maths that if you multiply a number by a number that's less than 1, your answer ends up being smaller. So if I do 50 multiplied by a half, or 0.5, that's the same as dividing by 2. And 50 divided by 2 is 25. 50 multiplied by a half is 25. If I make this really high, take it up to 100, I've now got a current of 0.25, or a quarter. Multiplying by a quarter is the same as dividing by 4. So 100 divided by 4 equals 25. 100 multiplied by 0.25, or a quarter, is 25. Now there's a picture set of questions attached to the Show My Homework assignment. You'll remember when we did speed equals distance over time that we could do the equation in different ways. So we could do speed equals distance divided by time, we could do speed times time equals distance, or we could do time equals distance divided by speed. So there's different ways of sorting the equation out depending on what you know. So if we know resistance and current, we can figure out voltage. If we know voltage and current, we can figure out resistance. If we know voltage and resistance, we can figure out current. As long as you know two of the things, you can figure out the third one using the equation. The questions on the sheet are very easy. They don't require you to use different versions of the equation just yet. Every single one, I give you the resistance and I give you the current. So all you need to do is follow the example and then work through the partial example and then do the other three. And upload that when you are finished. If you get onto the extension, you'll want to delete your bulb, and then over here you've got a list of components. If you click on this arrow down here, then you start to see some others. I'm going to suggest that you don't use the fuse, because that's a little bit weird, but use the dollar bill, the paperclip, the coin, the eraser, the pencil, the hand and the dog. You could even use the wire as well. Some of them, for instance the paperclip, when you put that into the circuit, it does something like that. Don't worry about that. Just notice that the little symbols in the circuit, the charges, are going around. So that's working. I know it's on fire, but we'll say that that's working. If you put in something like the eraser, that's American for rubber, they don't move. So have a little look, have a little play with some of the other things, some of the other objects, and have a think about what do the things that let the circuit work, like the paperclip, what do they have in common? The things that make the circuit not work, like the eraser, what do they have in common? See if you can figure out what the link is there. Okay?